actually past noon with the 12:40 mark. I know we are the last one before lunch, but we've got some great content, some great ideas, some great panelists here. So the panel is Silicon Valley is innovating quickly to build better products faster, covering tools for continuous integration and delivery, tips and tricks for DevOps, lessons learned, and how startups can use technology to bring products to market faster. Bringing products to market faster is a good thing or a bad thing? Somebody over here is awake. Let's ask that question again. Bringing products to market faster is a good thing or a bad thing?
Good thing.
Good thing. All right, good. So my name's Josh Holmes. I'm moderating the panel for Microsoft.
I'm Edith Harbaugh. I'm CEO and co-founder of LaunchDarkly. LaunchDarkly is a continuous delivery tool, feature flags as a service to help developers roll features out to their own users faster.
I'm Paul Biggar. I'm founder of CircleCI. I'm from Dublin. And CircleCI does hosted continuous integration, continuous delivery, so it allows developers to ship faster.
My name is Matt Harris. I'm a Canadian now living in San Francisco and the founder of a company called Sendwithus. Sendwithus does email template management and optimization for transactional email.
Okay, fantastic. So, as we're talking about startups and bringing products to market faster, one of the big buzzwords there, it's in the description here, is continuous integration. So let's start with what is that?
So continuous integration, kind of two major parts of this are continuous integration and continuous delivery. Continuous integration is the idea that every time you push code, it'll automatically be tested and validated so that you know that your code works. The idea of continuous delivery is that you take that one step further. As soon as you know that your code works, you ship it out to your servers so that your customers get new code every few minutes or every few hours instead of having a quarterly or a weekly or an annual release cycle. And the idea is basically that allows you to ship code a lot faster.
Wow, okay, so that seems a little scary. Is continuous delivery good? Why is it good?
It's good for a variety of different reasons. Number one is the business value it provides. If you have a release that takes 3 months, 6 months, or a year, you have these long cycles where you don't really know if users even like what you're doing. It might be broken. You might be heading in a completely wrong direction. But by cutting down the cycles so you're quicker, so you're even releasing the same day or the same hour as somebody asks for it, you can have a much quicker feedback loop of, am I going in the right direction?
Yeah. So one of the things that is particularly important for startups and especially for small startups is the idea of validating whether you're not just whether your code works, but whether your customers actually like the thing you're doing. Getting to product market fit very, very fast. And continuous delivery, if you're shipping every 6 months, you're never going to find out because you're going to get one release out and then you're going to run out of money. If you deliver to customers every single day, you're able to email your beta customers and say, what is this feature like? Do you like it? Is it a thing that we should continue working on? It allows you to make sure that you focus on the things that actually are going to make your business successful.
And not even email them, maybe just push stuff out and see does anybody even notice or care.
You use the metrics and see what happens.
We have a really unique case of how continuous delivery helps us, especially as a really small early-stage company. We maintain API clients in like 10 different languages, and when your team is less than 10 developers, it's really hard to stay on top of those and push changes, especially when they're open source and you have public people contributing to them. So we do continuous integration and delivery for all of our API clients. So when one of our developers makes a change to an API client, or someone from open source contributes to one of our API clients, as soon as the unit tests run and it sets us okay, the pipeline client gets pushed out to PyPy or wherever automatically. So it reduces our development load incredibly and allows us to have like awesome API clients for all of our customers.
How have you been doing this from the very beginning, or when did you start moving so quickly?
So we put in continuous integration, like automated testing of all of our API clients right away, because when you're a Python developer by nature and you're a two-man startup and you're just getting ready, and you start writing C#, you want to ensure that every time you make changes to it, it's going to still work. So unit tests come right away, continuous integration comes right away. As soon as we started getting open source contributions, like our customers contributing to them, we put in continuous delivery for it, because trying to remember how to deploy, to different online repositories for API clients it can be a headache.
So do you do for every single push? Do you release something like? Do you put up a jar or put something on PyPy or?
Yeah.
Okay. So every single commit or merged pull request becomes a new version number, or what do you do?
Yeah, sometimes we try to batch them, but basically we have automated like micro versions in each API client.
Okay.
Yeah.
Is there any day when you would not do a push? I mean, how continuous are you?
We deploy our API clients. We deploy almost every day. Our own product as well. We deploy multiple times a day, and I think we've done that since the very beginning. I mean, speaking about trying to validate your product as quickly as possible. Like, continuous delivery is vital to that to a startup. Everyone talks about moving lean, but like the nuts and bolts of moving lean means you're delivering product updates constantly, testing value constantly, and that's your continuous delivery is your feedback cycle. That's how you know, like, did we push something new? Did someone actually use it?
All right. There's this idea of reducing risk when you're shipping code. If you ship code and it's an entire week or an entire month's worth of code, and something breaks, what do you do? Do you try to fix it, or do you try to roll it back? Do you lose a month's worth of stuff in order to fix that bug? Or instead, you can deliver things in one small fix every time, and then whenever that goes out, and if something breaks, you can immediately roll that back. You lose one thing, you lose one developer hour of productivity instead of losing the entire month.
It's kind of like when you were talking, Paul, it reminded me of an autosave.
Right, very similar to an autosave.
Like you can, if it gives you a lot more flexibility. If at any time you always know you can reverse what you did.
Right. So when we release at CircleCI, every time there's a new push to our main repo or to the master branch of our main repo, we'll automatically package that up into a tarball we'll put on a server, so we can actually roll back not just to yesterday's release or the previous release. We have an archive of the last 100 or 1,000 or whatever releases that we could theoretically go back to if we wanted to. And so when we push a new thing out, we know that we can go back to the old thing. And the risk of the normal thing, or the other way of doing it, is to roll forward to try and frantically fix a bug, and that results in downtime. It results in death marches that developers hate. Everything is wrong about that.
Well, it's when you know you have a bug and you can't fix it, you get in this panic state.
Right.
And that's usually when you start making more mistakes.
Right.
Because you're like, let's fix this one thing, and you forget about this other thing that breaks, and all of a sudden everything is broken.
One of the things that you see breaks a lot is when you're trying to get something into a quarterly release or trying to get it into a weekly release or whatever, you'll just push things that aren't quite ready to be pushed, where there's a much higher risk. And if you've been working on something for 2 months and you can get out now, or you can get out in 6 months.
Yeah.
So you'll push it, and then you'll really risk fucking it up.
Yeah, I just read there's this rant online from the Linus Torvalds, the Linux founder, well, not Linux owner, about I'm not taking this change right now because it's just too late in the release cycle. But he says it in a very blunt way with a lot of swearing.
Right. I did that on the. So I used to work at Firefox, and the first time that Firefox moved to a fast release cycle, it's called the release train, which is a sort of a continuous delivery light. If you have something like Firefox where there's a lot of where it's actual downloadable software, so they switched to this thing where they were going to release every 6 weeks, and I was very excited about getting this change into the first release of it. And so at 6 a.m. in the morning, just before it was released, I pushed a change which broke Gmail.
Oops.
And then I went to bed.
No biggie.
Yeah, so the next morning I came back to a massive shitstorm that I had slept through.
And that was how you converted to continuous delivery.
I mean, the switch from at Mozilla, seeing them switch from an 18-month delivery cycle to a 6-week delivery cycle was actually the first major thing where I saw faster is just the difference between being an amazing product like Chrome or let's say something more like Safari.
Yeah, I think. I think one of so there's the business benefit that if you have stuff in smaller chunks, you could just move faster, like Matt said.
Yeah. Do you think a startup can put in continuous delivery too early? I would add to that. My thought is that most early stage companies don't launch fast enough, and by being continuous from the very beginning, you force developers to launch right away. As soon as they put it into the master, it's going out live.
The question there is whether the trade-off of the investing in the automation is worth is worth the speed of the automation itself. And I think that if you're a very, very early stage startup and a push is basically, or getting code out to your customers is basically a Git push, whereas an automation might take you, several weeks of something, and then that might not be the architecture that you stick with. There might be a case that's a premature optimization, but I personally always put continuous delivery as the very first thing I do on a new project.
Yeah.
I'll give an example of one of our customers who they said they stopped doing continuous integration because it seemed like too much work, and then they realized that they were just batching all this work because every time they actually wanted to do a push, they didn't actually trust any of their code. So it's kind of like the difference between doing your dishes every day versus suddenly having this huge pile of crap that you don't even want to look at. Right. So it's the little tidying of putting some automation in actually save them work.
Cool. So, I mean, your question there brings up a thing. What are the risks involved in continuous delivery? What's the dark side of this?
Yeah. Something we see quite a lot because we're an API client, so we integrate into people's products. There's more and more online services now that you're likely to integrate into whatever you're building, and they take things out that normally would be part of your code base, and so now they're kind of out of sync. So you might work on a new feature release, but in our example, if there's an email that's related to that new feature, it's not part of your release cycle. It's not going through automated testing, so it's now out of sync. This is one of the big risks we see with continuous integration. It's like how do you overcome things that are these services you're using now that are replacing what used to be in your code base?
Right. You have to check old versions versus new versions, and so you need a migration path. And so one of the risks is that it's always faster to just take your website down, do the migration, and then take it back up. And that has obvious problems of its own. But
that defeats the whole purpose.
Right, exactly. But it's faster and it's more efficient than doing it the other way. And one of the risks of continuous delivery is that you actually have to have a migration plan to keep your website up the whole time.
Okay. So, I mean, you brought up a point there a minute ago about you pushed something that broke Gmail and you didn't realize it's a small thing maybe.
Yeah. Well, it only went out to like 1 million people.
Right, yeah, no, just 1 million of our closest friends.
Fine.
Just all of Ireland.
Yeah, small bug among friends. We're all okay with this. So, but like you're doing API stuff, integration tests can test your stuff, but how are you doing testing with everybody else and making sure that you're not breaking them?
When we're deploying our own products?
Yes.
It's especially when you have an API. When you have a JSON-based REST API, customers can do really weird things with JSON that you don't really expect. And sometimes you'll push a change that makes your API more strict. Like now all of a sudden you're checking that something is definitely an integer and is not a string. And there's customers who are sending you integers as strings in the JSON payload. And your API, your unit tests still pass, but now your customer's using your API,
They're using it wrong.
Arguably, they're using it wrong, but our unit tests were correct, and they passed our continuous integration test and went deployed, but then we get production errors from customers.
So I think the risk there, or another way to state that risk is that you need to have really, really solid monitoring. You need to have really, really good metrics to know when you start to break customers and when things start to go wrong, and then also you need to have obvious 24-hour support so that as soon as you start to see things go wrong.
I think we're talking about one of the risks in terms of the risk of like failure, risk of a bad response. But the other risk of that comes along here is the risk of deploying something that people don't use, and that's why the feedback loop is so important. The feedback loop for seeing errors is really important, but the feedback loop of seeing lower usage is really important too. I think Facebook's really famous for this. When they launch out a feature, they can just see did engagement drop with this feature release, and it's they don't even have to know that something went wrong or that the screen didn't appear correctly or that Gmail broke. Engagement dropped. Let's roll back that release.
Yeah, Google is fascinating. I mean, they have this down to science because basically some things they're like we can't even test it in house. Like you can't replicate Google's load without being Google. And the same with Facebook. They're like, we cannot replicate the volume that Facebook has without just pushing. Google actually has these really sophisticated metrics where they'll even track whether Gmail sucks is spiking on Twitter. And they're like, okay, something went wrong and we're going to roll back.
Yeah.
So a big fuck up that I see smaller companies do, when I say smaller, anyone who's not kind of Google or Facebook, is that they is that they have separate business metrics and operational metrics. So you have an operations team who's keeping an eye on the database load and on the amount of 500s or exceptions in the web stack, and then you have a business team which is making sure that that the marketing funnel is working. But you can introduce something accidentally that breaks the marketing funnel, and so you need to be making sure that when you do your metrics or when you're deploying code and you're looking at the metrics to see if you need to roll back, that you're taking into account your marketing funnel, your A/B tests, your KPIs, whatever those things are, and then vice versa. If you're doing some A/B tests on the homepage and all of a sudden your database spikes, you're not going to notice it if you're in the marketing side of things and not in the operational side of things. So you need to unify those things, or else it's going to be very difficult to continuously deliver reliably and safely.
And also, they're tied together. I mean, a lot of new features are slow just because they aren't instrumented. So I heard a story from Andy Dillon, who's now at AnyPerk, where at Yammer they deliberately tested a new feature, and then they tested it with like a 0.5 millisecond delay, because nobody believed him when he said like performance mattered. And then like exact same feature went a little bit slower, and its business metrics tanked it with it slower.
Oh, interesting.
And
It's kind of like an AA test.
Well, because before that, he kept trying to say like performance matters, but nobody would listen. And then after that, a lot of new features fail just because they're slower, and people are impatient.
Yes, we are.
So
Moving on.
I'll tie a risk to that, and there's the risk of delivering things without validating them. So you can now, you're now a developer. You can just write code and you ship it, and it goes out to your customers. And you don't think to say, is this a feature that a customer really wants? Is this a feature that we've validated that a customer wants? And there's opportunities to slow roll it out, to use feature flags. And if you don't do that because you feel you know best, or just you want that feature yourself, there's a risk of damaging your product.
I think there's a lot of humility involved in continuous delivery. Like there's the humility that, I have this theory that this new feature is going to be awesome, and I'm going to try it out.
Right.
Like I'm not Steve Jobs. I'm not always right. In fact, I'm happy if I'm right more than half the time.
Just want to throw this in. We do something really cool on the validation side, and that I think many other early stage companies can replicate. A lot of people here probably use Slack or another chat service that's like that. One of the things we do with every new feature release, every new feature is we get real-time inputs back into Slack based on how people are using it. So we have a logs page. We added in filtering and searching for logs, and it was freeform. You could type in anything. You'd be like, did this person open this email and find that log? And when we first released it, we piped every search real time into a Slack channel, so our developers who launched the feature can see what people are actually searching for. Did users figure out that they could type in like opened email X or open template name or all these things? And we do that for everything we do. We implement real time feedback so that our developers see what people are actually doing with it.
Yeah, I think another huge benefit of continuous delivery, what Matt just talked about, is every engineer wants to see their code out there working and feel it's valued and used. Like it's terrible to spend like a month or a week or even a decade on something and then find out that nobody actually cares.
Right.
Like so, Dave McClure, one of our advisors, he said, it's better to be hated than to be ignored.
Right. Oh, absolutely. So
Well, you're at Microsoft.
Paul.
Yes. So I've had both of those things, just saying. So question for you though. So you talked a little bit about kind of molding the business and helping shape that around some of the stuff that's coming out of this continuous delivery. And then I've also heard, we've thrown around these terms like automation and, all the monitoring stuff. So, there's business transformation, but there's also some tools transformation. What are some of the tools? What are some of the other stuff that goes into this that's going to help these guys?
Well, I think to start with, you need a continuous integration server.
Yes.
Such as CircleCI.
Yeah.
Are there any other
Notice
tools?
the subtle plug. Just, yeah.
Edith, any other tools that you think are useful for continuous delivery?
So the biggest companies like Google and Facebook have built their own tools. Facebook has Gatekeeper. Dropbox has a system they call Gandalf for none shall pass.
But if you were a smaller company, what tool could you use?
Somebody smaller than Google or Facebook?
There's only a few of those.
Yeah, so my company, LaunchDarkly, makes a platform where you can roll features out and then quickly reverse them. And Paul is trying to encourage me to give a shout out.
LaunchDarkly is awesome. We just started using it.
Yeah, thank you, Paul.
So other tools that you can use apart from things that are made by people on this stage. Monitoring, I think, is a super important one. If you're not using something like New Relic or Datadog or something to do your database monitoring or your operational monitoring, and also something, as I said earlier, to use for business monitoring like Mixpanel or something like that, you're going to find it very difficult to do continuous delivery in a sort of safe way.
And you're actually doing continuous delivery all across a number of different programming languages, and I'm assuming platforms as well.
Yeah, we continuously for like API clients for our own product. We do like a microservice architecture, so it's like different little services are all being delivered, and then it's not just our own API clients, but then it's like an API client and then like a platform client basically. Yeah, it's pretty insane. I think one of the things you're seeing is like CircleCI and like the continuous integration services are kind of like the baseline, but you're starting to see more and more services added into your stack. So your stack isn't just the code base and then like the frameworks you use, but it's also the other microservices you drop in that you may or may not be writing yourself. And the question for like what's coming next or how you plug into that is like how do third-party microservices continuously integrate with you?
So I think that's interesting from a tools perspective. So when it starts to get into the architecture of your code and how you communicate with those services. So the very common thing that people do is they just, there's a REST API, they'll just communicate over the REST API, they'll do it synchronously, they'll wait for the result. And then the server will go down, or the server will be slow, or there'll be a network partition or something like that, and your architecture just won't be ready for that. So when you start to look at, or when you use a lot of third-party services, I think you need to treat them exactly the way that you would other services or microservices within your own stack. You need to connect them via queues, you need to have retries, you need to have monitoring, you need to do things like using Hystrix or things to have back-offs in case you take the service down. There's a lot of like standard distributed system architecture things that you should use to be connected to those services reliably.
Awesome. So all this brings up, we've seen this amazing evolution in how we deliver software. Where's this going?
I think evolution is the right word. I think that just there's a real urge to get software faster and faster and faster so that it gets better, quicker and quicker and quicker. I think we're at the very dawn, I'd say, of continuous delivery, where there's this realization that if you move faster, you could then reduce risk, you can build better products, but I think a lot of people are still trying to wrap their head around it. I know, I've been building software for over 20 years, and it was very scary to me at first. I was just like, well, wait a second. What if we don't have a 4-week QA cycle? What if a bug happens?
Right.
And I think a lot of people are still in that place, which is a place of, I've known what's worked in the past, and I want to move faster.
So related to that, there's this, it used to be that the software that we were running was running on a fairly reliable thing, like it ran on your computer, and your computer's relatively reliable. But now the software that we're building is largely built on distributed systems. It's split across many machines and different availability zones and different regions and different data centers, and there's just distributed systems everywhere. And distributed systems are inherently faulty, and they fall apart. And so when I think that part of the next evolution of software, and part of the reason that continuous delivery is essential now, is going to continue being essential in the future, is that there's just faults everywhere, and we'll need to start taking care of it. And the next evolution is, I think, raising the level of abstraction in how people write software. We're still writing things. We recently moved to do memory management automatically. We're now using Ruby and Node and things that are automatically memory managed, and that's basically the highest level of abstraction that we've done in the last 10 years. But we're not looking at software that automatically figures out how to run across many distributed systems, that's automatically fault tolerant. We're still doing everything by hand, and I think that has to change if we're going to really be able to scale these things.
Yeah, I mean, I just read an article about the Voyager mission and how they're having a hard time now because back then not only did you have to program, you also had to manage your own memory by hand. And I think people in 40 years are going to look back on the tools we use now and be like, it's amazing that people wrote that themselves. Like, why did they concentrate on the real business value and the real fun things instead of all this low-level abstraction?
We write the same thing all the time. We write calls to third-party services over REST API. We're just there's a new API client, and the new API client has a different way of communicating than the previous API client. And is there the right level of fault tolerance in that? Is there the right level of retries? Can we make sure that we actually do the thing for the customer that we said we were going to do? And right now, I'd say the answer is only if you're going to manually do that for every single thing, and to really dig deep into the stack and the frameworks that you're using to validate that.
So we talked about this before, but I actually completely disagree with them.
Excellent. Finally, we have some
Ooh,
disagreement.
fighting words as we're out of time.
So,
30 seconds. 30 seconds.
30 seconds. If you look at the two only big companies in the world, Google and Facebook, neither of them are investing in higher abstraction languages. Google's just invented Go and heavily investing in Go, which is not that much higher level language. Actually goes.
They were starting
goes
at C++.
down stack.
It was a
Well,
terrible
no,
level.
it's his 30 seconds. It's his 30 seconds.
Yeah.
Go.
Same with Facebook. They're heavily invested in more C-based and PHP-based languages. Like they're not going to higher and higher level of abstractions. They're going to let's go to more specific languages that are more performant and still very low level. So I don't think the future is more higher level abstractions for these things. It's more specialized languages that are more performant at certain tasks. You're going to have your languages for queuing. You're going to have automation languages that help make that, but they're all going to be very, very specific and still very, very low level.
So that sounds like a fantastic panel for next year. What do you think, guys? Would that be an interesting panel, that conversation? All right. So I hate to say that we're out of time as we get to the fighting words and the really, really, fascinating stuff. It affects business, the architecture, the delivery, your customers. There's a bunch of things that it affects. But I would love to get on to that next conversation. But next time, thank you.
Thank you, Josh.
Thank you.